Okay, hello guys, I am Joseph Donahue, and thank you for coming out for my senior projects presentation. Who am I? I am a senior here at Donahue High School. I'm currently in my 4th year of being in the engineering courses here at Donahue, being from technical drawing to where I am now in senior projects. I'm also having in engineering. I have 4 certifications within our program called SolidWorks, which is a CAD software. I have my CSWA, my CSWP, and the 2 advanced topics being sheet metal and drawing tools. Over the summer, this previous summer, I interned at a place called Riata Engineering Machine Works, where I learned a lot from the manufacturing side and partially from the engineering side there. And now I'm currently an engineer and drafter there full time. And this upcoming summer, I'm going to be doing an internship possibly with Boeing. And then after the summer, I'm going to be starting my 2 years at Red Rocks Community College and then going off to Mainzer, finishing my degree in mechanical engineering. Another place I want to add is also I'm an avid motorist, which you see I have 2 bikes, one being a cruiser, one being a sports bike. My project this semester was to create a heads-up display accessory for a full-face helmet like this. And a heads-up display basically is an image projected onto a clear surface like a windscreen. And the reason why I do this is because of either safety and affordability. The safety aspect comes from when you're out riding, you want to try to check your speed. You can see that when I check my speed, I can't see much of the road, which that's pretty bad, because if someone's in front of you, you can't see them, that's going to be into a really iffy situation. With heads-up display, I'll be able to keep my eyes on the road full time, as well as being able to see the information needed, such as speed, time, rear view capability, and GPS navigation. Pricing, being the affordability part of this, is for similar products that are all on the market today. One being the NewViz heads-up display, which is similar to what I have, is about base price about $600. The other product is the Scully AR1 full-face helmet, which has the integrated heads-up display in this area, rear view camera here, and it's also voice activated using Siri. It's only $1,500 because everyone has that in their pockets. What I wanted to try to do with this project was create something that was less than $400, which I did succeed in the end. My project objectives this year were to acquire the rest of my CSWP advanced topic certifications, which will make me eligible to take the CSWE, which is expert level certification, which is the highest we have. And right now in our student project class, we currently have 2 people, which is 5 people in the state, which is 5 in the world. So congratulations to those people who got it. And as well as that, I want to be able to learn how to code and learn how a board works, because prior to this project, I have 0 experience coding in any sorts. So I was really stepping out of my comfort zone and trying something new. I also want to learn how to create a projection that can be put onto a clear plastic, which is basically heads-up display, which I'll explain here in a couple of slides. I also want to learn how basic electronics work, which in After Effects, I really didn't have to really learn much about it because I didn't have to do much of the electrical aspects of my project, just simple wiring, and that's pretty much about it. And by the end, I want to figure out what engineering field really speaks to me, which I'm pretty sure now is mechanical engineering with a bit of minor in aerospace, so that is settled now. The company logo is MotoHUD. MotoHUD is being motorcycle heads-up display. Within a MotoHUD, you can obviously see there's a motorcycle showing that this applies to a motorcycle. Within the motorcycle, you can see this little arrow here showing innovation, forward thinking. The colors behind it I chose is red, being the adrenaline you see when you go out and ride and have fun all day. Really experience pretty much near-death situations all the time because at any situation it's bad, so I want to be safe now. And the black shows the professionalism and the strength of my product, showing that no matter what, you can trust it and it will always keep you safe. That's the biggest priority. For my advisory committee, I have for my expert advisor, Dan Breezy, who is here in the audience today. He is a senior software engineer at a company called Trustwave. And my supervisors, being both my mom, dad, Rich, and Karen Donahue, were there for me morally and financially. And for my other two supervisors, I have Ivan Lukov, who is very experienced in the field of programming and who has helped me a lot throughout this process if I ever need something to be worked on during class. Sam Mock is one of my other advisors. He's also very, very well coordinated in the aspect of programming, and it also helps out too. My research part was mostly trying to figure out what heads-up display is. What heads-up display is basically a projector displaying an image on a wooden screen, like a wooden shield, as so represented here. The way the projector works is basically there's a light source down here projected through a transparent screen. And one thing with this is there does not need to be two mirrors to reflect the image. You just simply have one being an aspherical or a concave mirror so that it can reflect the image and then enlarging it to a good size so that it's not too tiny or too big so you can see it very clearly. And when it's done, you can see the image in front of you with color and such, which I was trying to go for here. For this, I had to then figure out that with this projector system, it actually is not feasible without spending a lot of money. The reason why I have to say that is because currently, like everyone knows, Google Glass, which I do not have, but I did get in contact with a company called AMX who created a similar product here, which is similar to Google Glass, which also has, inside here is little projectors, which basically reflect off two mirrors in the corners, and it combines them here and reflects into my eye, which creates the image that I can see. When I have this on, the image I roughly see is about the size of this projector from wherever you guys are sitting. So you can see that obviously does obstruction view, but with what I was trying to do, it just be off on the side, just being there, not obstructing view. But with this product I'm holding in my hand is worth well over $5,000. And that does seem like a lot. You're saying, well, if you want to try to do that projector system, you're saying, wouldn't that cost a lot of money? Actually, it's really not the projector system that costs a lot. It's actually one of the cheapest parts of the project of this. I got in contact with AMX and he told me that the projection system here is only about 20 bucks, which that's very, very cheap. The reason why I'm not able to get it at my level, at the consumer level, because these are built at the big bulk, big manufacturing companies where they buy millions upon millions of these parts. So it's kind of hard to get in contact with any company who actually fix these. With this, I had to go with the hardware, which was just simply the display, as I showed here, which is a TFT display, which is about, say, it's a little bit bigger than 2/4 side by side. A GPS, a Raspberry Pi, which is a little computer board, and TTL to USB, which TTL is basically the little pins here on the Raspberry Pi. And not the Raspberry Pi, it goes onto the pins connected here onto the GPS and connects via USB to the Raspberry Pi. Later in the project, I do get rid of this, but I just easily just wire it directly from the wires here to the GPIO pins there. Here you can see is my initial aspect with the USB to TTL connection connected to this GPS after it has been soldered. Soldering was pretty easy. I've had some experience with doing it, so I have no biggie, did frying board because that's not cheap GPS. It's only 40 bucks though. And here you see, next step was install some software. So the software was called GPSD, which basically is the translation of the information received from satellites and inputting it into the Raspberry Pi into raw data. As you guys can hopefully, I guess it won't put it on here, but so it doesn't take up time, you will see that it starts spitting out raw data. I guess in retrospect this should work, but the data that's coming was incomplete because for a GPS to work, you have to get a connection between 3 satellites so that triangulation would happen, so they'll know where you are and know your precise location. Most of the time, I was only able to get one satellite to really connect at all, if that was happening. And that even worked if I was outside on a clear sunny day. So I couldn't really figure that out for a while. Because I did look online and try to figure out what was the issue. Was it the part of my coding that when I installed it went wrong, or was it something in the software? After finding out, it's probably with the software, knowing that this GPS wasn't made for a not Raspberry Pi, but an Arduino board, which is written differently than Raspberry Pi. Another thing you see here is this is the output from a different command, which basically interprets the GPS raw data into something more of a symbol like speed, height, latitude, longitude, something that we can make sense of. And also, you see it keeps timing out whenever I try to run this command because there's no connection with satellites. So this GPS didn't work. I spent such a good month or so trying to figure this out. Couldn't get anywhere because no documentation was out there on how to fix this kind of issue. Next part was, because I didn't get the GPS to work, was to start working on a code that I can get to just spit out data so I can at least work on my next part, which is the display. My first program here is basically inputs the data received from the GPS and outputs it here. The GPS only prints off a certain amount of line of code, roughly about this much, every half second. Normally, this actually might work in the video, so let's see. It's sideways, but you can see that the data here is being outputted and continuing to do that. Knowing that the GPS doesn't work, the output here is just zeros and NA is being full and no information is being outputted. But at least from here, I can really see that I do have working code that works. Next step was to pretty much redesign and make it much more better and simplistic, other than just having a long, long line of results, which wouldn't make much sense if you're on the road. As you guys can see here, the code is a little bit lengthy, but to really put it down in simple terms, it basically, the GPS would input the data and then run through some different commands, which will interpret, say, the speed and time and such. So the raw data out of the GPS would be used so we can actually display it the way we want to. As you guys can see here, this is the final piece right here that shows the speed, the time, and the accurate dates. And this could also be changed to kilometers an hour just by just changing some parts of the code to that different version. Next part was to be able to get this code to display onto the screen, which was my next step. Doing this required to wire up a Adafruit 1.44-inch TFT display to the Raspberry Pi. Like I said with the GPS, this as well is made to be put onto an Arduino board. So then, in retrospect, I have to then do some more research on how to make it work on one another. That's where I get to the part of making a kernel. A kernel, in simple terms, is basically a translation from one piece of software to another so they can understand each other and know their formats of inputs and outputs. During this process, I did run through an issue, which I'll get here in a second, but we'll at least roughly get through how a kernel kind of works. When you create a kernel, you have to install a thing called kernel sources. Kernel sources are basically a template of what you need to make this kernel. Next part was called to install the TFT files, which is just the files which the TFT display uses and makes sense of it in the Raspberry Pi. Then the next step was to configure this so that the TFT files knows that there's a display connected. This is the part of the project which kind of got me caught off guard because it wasn't really straightforward, it was very vague. And because there's not much documentation on how to do this, especially for a Raspberry Pi for this specific display, there's not much on it out there, so there's not many people documenting on how to fix this kind of issue. As you guys can see here, it says, to make the kernel aware of the connected displays contained in this file location, include this piece of code. Finding And actually getting the right place to put this code in was very difficult because I couldn't figure out how to really access it, nor was it, when I put it in, was not in the correct place. Trying to do some research on how to do this, nothing really popped up because this is a very rare kind of situation with the specific display, with the specific board and the operating system we use, and also code being Python. And overall, I couldn't get either GPS or the display to work, so I now just to improve the concept. And this is actually the final display here, which I actually do have with me right here. It is attached to a helmet, and theoretically, this could work if I was to just change one thing, which is the Raspberry Pi located inside the helmets. I just changed that to an Arduino, which is both made for the display and the GPS. With a couple more months of work in coding, I could probably get this to work. And yes, this does seem a little big, but it's actually not even that heavy. If you compare it to like your phones, it's a little bit lighter than your actual phone, so it's not really adding much weight to it. When I also changed it to that Arduino board I was talking about, it'll probably cut the size of this pretty much by half, because the entire base of this is actually the Raspberry Pi turned sideways. With the Arduino Uno, it's actually a fourth of the size of this board, so you pretty much can cut it all the way down to about this much here. Clip down on the size, the weight, and make it a little more aerodynamic in the road. And no matter what you do, this thing's not going to fall off. So I can pretty much throw it in, I'll be fine. And here's the final solid design of the shell of this little device here. And these holes right here and here are for HDMI cable here, and then just USB connections on the side. In the final design, this wouldn't be here. I just have to have it so I can at least connect to the Raspberry Pi and work on it. Pricing though, this is one piece I really like, is the final price of this is $180. That is well under a third of the lowest on low. If I was to go with my previous idea of adding a camera to this is only bring up to about 200. And if I were to actually be able to obtain that micro display, that transparent display I was talking about earlier that is not actually available, it actually wouldn't change the price at all. It is the same price as the display I currently have in it. Now it's on to my project timeline. In the month of October, it was just mainly a research month for me, trying to figure out what I would need for this project. As you see, I did go through some research, but I didn't realize that when I did what I didn't need a thing called an accelerometer. An accelerometer does give you speed and such, but the GPS is actually a cheaper and more universal tool than the accelerometer, because with the GPS, I can use it for multiple different things other than just speed. And as well, I did get the board, the programming language, the display, and the GPS that I need for this. In the month of October, I continued doing my research on the GPS and other things like the accelerometer, which I didn't need really, and the processor. In the later in the week, I just ordered in the hardware I needed, and then did my research on how to program the accelerometer, which in turn actually turned into the GPS. That is why this is read out, because I did not need an accelerometer or any of this. It turned out to be a GPS, which I needed. And also the processor, I don't even know why I added that in. I don't know what I was trying to understand from that. So that's when I'm going to myself about that later. In December, it was time to assemble the GPS and board, and then pretty much finish doing that, and then begin programming that GPS by the end of the month. I didn't get around to the GPS because when I ordered the hardware online, the company after which I got the display and the GPS from, they were completely out of stock for a couple weeks, so I had to wait for them to get back in stock and then order it. But I was able to get it back in the second week and actually finish the assembly, like I showed earlier, and get all that done. And then because of this, I kind of got delayed on the research and programming, because I had to actually start the research and do the programming later. In January, I want to continue doing that research and then try and get that information to display on the little TFT display I had. Then it came up to mid-year presentations. I did get around to doing the research program of the GPS, But I did not get at all to the data display because the programming did take me through that time on 2 days of video presentations. February, I wanted to continue and finish researching programming with this data to display, and then start beginning my research on the heads-up display, which was in turn going to be that projection system I talked about earlier. But after the research, I just tried to do the reflection display. And kind of seeing now that none of it was really done, because by the time I got to get the GPS, try to get the research on how to get the actual display to work, didn't work at all. And it took me quite a long time to actually get it to work out through this month. Coming to March, I want to finish up the heads-up display, 3D print the shell for the Raspberry Pi, the GPS, and the display. Start programming the camera, and then pretty much try to finish that month. I did not get to that because the heads-up display idea was kind of thrown out at the very beginning. And I didn't get around to getting the camera to work because I was trying to work on the display during this time. Then it comes to April. April, I was hoping to finish up the heads-up display, create the final products, and then work on the final presentation, and here we are today. I didn't finish the display, but I did work on the presentation, so you guys are now actually seeing the final results of this product right now. And that is everything. Thank you guys for listening, and does anyone have any questions?
Even though that I know what a kernel is, I know that a lot of people here probably don't know what that is, so you should probably give a more clear explanation of that.
How I kind of understand it is kernel gets the information from the TFT display, which is its own software, and it tries to translate it into the Raspberry Pi 2 information it can understand through its own files and directories through the FBTFT file diagrams. To answer your question.
How would it affect safety? Like, if you fell on your face, would it come off, or would it stay there like?
It would immediately pop up because it's just held down by 3M tape. It would be like the same thing with the GoPro. Once it pretty much takes an impact, it will just pop right off.
So then if you were going fast enough, wouldn't it fall off too if it was just held on that way?
Repeat that?
With like, if you were going fast, wouldn't the drag from the air make it fall off if you too? If it's that
actually, no, because with my GoPro, I've had it on the side of my hallway going 75 down the highway with high winds. It didn't even budge. And with this, it should pretty much do the same. It's held on by the same kind of adhesive. It is a tiny bit bigger, but it's not much different from the GoPro. Any other questions? Thank you.
All right.